All right, so the general idea in this one is that functions can be even or odd, or they can be neither. So I should probably add that to our learning target today. The definition of an even function is a function that has the y-axis as a line of symmetry. So for example, down here I see a parabola, and in this parabola the y-axis is the line of symmetry. So this function would be called an even function. And to verify this algebraically, it's even if you put a negative x into the function and still get the same function back out for any value of x that you put for the domain. And then an odd function has rotational symmetry with respect to the origin. So what that means is that the origin is a place of symmetry. So if I rotate it around 180 degrees, it's going to be exactly the same. And in this one, if I put a negative value of x, it makes everything opposite for all values. And then also there are times when it is neither. Okay, so it doesn't have any type of symmetry. It's not even or odd, and something funky happens when I put negative x in. So we're going to do a couple of these. I'm going to leave the last one up to you. So we're just going to determine whether these are even, odd, or neither by putting, we're going to input negative x in place of x. And so that's what this means when I say f of negative x. So I'm going to look at this first one. We're going to think about 3 of negative x squared. And what I know is that when I square a negative number, it's still going to come out the same as its positive counterpart. So for example, it wouldn't matter if I did 3 times negative 1 squared or 3 times positive 1 squared, or any other positive or negative version of an integer. It's going to come out the same. And so 3 times negative x squared is the same as 3x squared. So this function is even because, like I said, it is even algebraically if you put a negative x in and the function comes right back out the way it started. Let's look at the next one. Let's think about 7 times a negative x instead of 7 times a positive x. This would get us the function as negative 7x, which is not the same. However, when I'm looking at this definition, the whole function is the opposite. I know there's only one term, but the term became the opposite of what it was. So this is an odd function. Then I've got the next graph here, or the next equation here, absolute value of negative x plus 1. And this is another situation where when I take the absolute value of negative x, it's no different than when I take the absolute value of positive x and add 1. Okay? And so this would be even. Next, I've got the square root of x. Think about the square root of negative x, which is not possible. So what I'm going to have to say is this is neither. And lastly, the cube root of negative x plus 1. And I don't think that this is going to come out as the opposite of what it was, and I don't think it's going to come out the same as what it was, because when I take the cube root, when I take the cube root of x plus, or of negative x plus 1, that's different than when I take the cube root of x plus 1. So I'm going to say this one is also neither. So go ahead and look at this last one here and bring it to class with you tomorrow.